All right, people who are gone, this is the second half of the 6-5 notes. It looks like a mess on the front side. The front side was just the indefinite integrals. This back side, we're going to be dealing with a definite integral. Okay, indefinite. Put this at the top of your paper so you can remember it. I'm going to say f of x dx, no limits of integration. That means it is an indefinite integral. Okay, versus a definite integral, let's say 0 and 4. Yes, limits. That is called a definite integral. Okay, f of x dx. Okay, so same rules apply. We're still doing substitution, but now at the very end we have numbers to plug in, okay? And there's two kind of different things that you can do when you are plugging numbers in, and I'll show you both of those ways and you can decide, okay? Good? Here's guidelines for for doing substitution if you want to look through those. I kind of made my own steps on the front side of this page when we were doing those yesterday, okay? Ready? Here we go. First example, and only example, I guess, really. First example, here we go. They designate as x squared plus 1 because it is the inside function. It is the function that is a composite function or stuck inside of something else. And then we need to figure out what du is. So what's the derivative of that stuff? What will my derivative be?
2x.
2x dx. Okay? And then we're going to start plugging stuff in. Okay? So, I've got my integral. I've got, I'm not going to write my limits down. I've got this stuff cubed. So I've swapped him out, and now I'm going to deal with him. Okay, swapping him out. What does he change to be? X squared plus 1 to the third power is now u to the third power because we're changing him, so we're making him look a little nicer, okay? Now the other things that I need to swap out are x and dx, and I see that down here. X dx is down here, except I don't need the 2. So how do I get rid of that 2? Bump him over to the other side, so divide by 2, and du divided by 2 is like saying 1/2 du, okay? 1/2 du is equal to x dx. Okay, I've gotten rid of the 2. He's now 1/2 on the other side. So, to substitute for x and dx, I'm going to do 1/2 du. Okay, and I put the 1/2 out in front so I don't have to deal with him.
Oh, but
okay?
why can't we put it in? Why the du?
I mean, you can, but just leave him out front. It makes it easier, okay? Now, we haven't found the antiderivative yet. We still have to do that part, okay? So, that was step 1 was u and du. Step number 2 was substitute. Step number 3 is find the antiderivative. Okay? Step number 4 is plug in limits. Okay, so we're going to get to that point, but we need to find the antiderivative first. So those are my kind of 4 steps if you need to have like a guideline here. Okay? So I have u to the third power that I'm trying to find the antiderivative of. So you can do 1 over n plus 1 x to the n plus 1. 1 over, what's n plus 1 going to look like?
4.
4, u to the
4.
fourth power. Okay, and then I've got 1/2 out in front that's just chilling, right? Okay, and so that would make like 1/8 u to the 4th power.
Yeah.
Okay, plus c, no plus c. Do we need plus c? Usually, whenever we take the antiderivative, we need plus c, except we're going to end up plugging numbers in, which means my plus c is going to go away. So we really don't need to do a plus c, right? Okay, good? All right, now, plugging back in your x's, I've got 1/8 x squared plus 1 to the 4th power. That's what he looks like, right? Okay, that is my full antiderivative. And now I'm going to put that little bar at the back that says we've taken the antiderivative, but we haven't plugged our numbers in yet. And I'm going to plug in 0 and 1. Okay?
C.
Good? All right. Now, we start by plugging in 1. So I've got 1/8 times 1 squared plus 1. That's the first part. And I subtract when I get what I get when I plug 0 in. Whoop, 1/8.
Why would you even put it on?
0 squared plus 1. Because this time it doesn't cancel out, right? It's not gone. Yep. So substitution, it doesn't always cancel out at the end. Okay?
So something minus 1/8.
All right, so, yep.
So 9
So-
eighths minus 1/8, so it's 1.
No, what
Yep.
are you, what? No.
I don't
No,
know.
no. Okay, what's 1 squared plus 1? 1 squared is 1, plus 1 is 2. What's 2 times 1/8? I'm gonna leave it as 2 eighths. I'm gonna leave it as 2 eighths for just a second because we're gonna need a common denominator here in just a second. So you're right, it is 1/4, but
So it's 1/8.
minus 0 squared plus 1 is 1, and 1 times 1/8 is 1/8. That's why I wanted to leave that as 2 eighths. So
Okay,
the answer
so
is
half fourth.
a half of a fourth, or 1/8. Okay? All right,
What'd you
good?
do to the-
What?
You didn't do to the fourth power.
Oh, crap.
Oh, damn it.
Oh, crap. I forgot my fourth power in there. You're right. Poop. Okay, get rid of that. Okay, so, backtrack. This was 2. 2 to the fourth power is 16.
Yep.
An eighth of 16.
2.
2 minus, okay? 1 to the fourth power.
1.
That's still 1.
1/8.
So, 2 minus 1/8.
15 eighths.
15 eighths or 1 and 7 eighths. However you want to write it.
15.
I don't care. Whatever way. Okay? All right, good? Yes? Okay, now, that's that process, right? But some people like to do this instead, okay?
Oh, sweet.
Backtrack to right here before we plugged the x squared plus 1 back in. And at this point, we found our antiderivative, 1/8 u to the fourth power, right?
Mhm.
Okay? Rather than rewriting and plugging the x back in, we're going to change the limits of integration. I'm going to say if x is 0 and x is 1, which is what our limits were here, I'm going to plug them in and find what u would be, right? You see what I'm saying? Okay, 0 and 1, if I plug 0 in, 0 squared plus 1 would be 1, right? U is 1. You see what I did there?
Kind of.
Okay? It's like taking these numbers and plugging them in to the u formula to change everything to u's. So if I plug 0 in, I get 1. If I plug 1 in, you get
2.
2. Okay? So changing them here, now I'm not going to plug back in for u and make him x's again. I'm going to leave it as u, but I'm going to use the numbers 1 and 2 instead of 0 and 1, right? It's just kind of, it's exactly the same thing as what you're doing, but it's less work to write out. Does that make sense?
Why can't you do 4 or 5?
What do you mean?
What do you?
But still, you can just save yourself from writing. By
What do you mean?
doing
Why
something
can't
in
you
your
use
head.
4 or 5?
Well, why would you do 1 and 2?
Because our limits were 0 and 1,
Yeah.
right?
Uh-huh.
So if x is 0 and x is 1, if x is 0, u is 1, right? Plug him in here, right? If x is 1, u is 2, right? You're plugging into that u formula right here. So you're changing your limits. Instead of it being 0 and 1 in terms of x, it's 1 and 2 in terms of u. Does that make sense? It's just one less step you have to do. So now all I have to do is 1/8 times 2 to the fourth minus 1/8 times 1 to the fourth, right? Which essentially is what we did down here, right? Didn't we get 1/8 times 2 to the fourth and 1/8 times 1 to the fourth, right? But we just did it a step earlier and less writing than it was before. So this is 2 minus 1/8 or 1 and 7/8. Okay, it's doing exactly the same thing, but just less work to write out because you're changing your limits.
Or you could just save yourself time by doing the last step in your head.
Right. Yeah. Okay, does that make sense?
Yeah.
You can either substitute your x's back in and write the whole thing out, or you can change your limits and not have to write the whole thing out and just leave it as u. Okay, happy with that? Okay, when I know that we've talked about this before, you can't see these bars very well, right? Okay, draw those bars out. Or there's that x and y axis. Here's the y axis. Here's the x axis. There's this function that goes like this, something like that. Okay, that's an odd function and an even function. Okay, ready?
X squared and x to the first.
This is like y equals x squared, and this is like y equals x to the first power, or, you know, it could be y equals x to the third power. Does the same thing. It doesn't look like this, but x to the third power would look like that, and it has the same rules apply to that. Okay, so you have an even function, even functions versus odd functions, okay? When you're doing the antiderivative, you're finding the area, like this area plus this area, right? Okay, So let's say that this number was -2 and this number was +2, okay? I would be doing my function. I would be going from -2 to +2 of whatever the function was, and I would find the antiderivative, and I would plug in -2 and +2. Or what they're saying for this is if it is truly an even function, nicer numbers to plug in would be 0 to 2, right? Go from here to here instead, but then I have to double it, right? Instead of going from here to here, I go from 0 to this spot, and I just take that times 2 at the end, right? Because this area would be the same as this one. Does that make sense? Plugging in 0 and 2 is a lot nicer than plugging in -2 and 2. Does that make sense? Okay. So if it's truly an even function, that is an option that you can do as well.
But you
right?
can't do that on
What do you mean?
Can't do that on an odd.
You can't do that on an odd function, but look at what happens on an odd function.
You do it on an x to the first because it's just mirrored.
Okay, just wait. So in an x to the first power function, let's say you're going from here to here. Let's say that this is 4 and this is -4, right? And if you're going the same, you're looking for this area combined with this area. So what's the total area going to be?
2 times that one. Wrong. You're wrong. I'm right.
Nope. This area is a positive area because it's above. This area is a negative area because it's below.
0.
So the area is going to be 0. If it is truly a
That's
negative,
so stupid.
if it's truly an odd function, the area will be 0 as long as you're going from like -4 to +4 or -10 to +10. If you're going from -3 to +7, that's obviously not going to be true because one side's going to be bigger than the other.
Negative.
Right, because then it's going to be more negative than it is positive. But if it is truly an odd function and you're going from the same things on both sides, the area a lot of times will cancel out to be 0. Okay? All right, so keep that in mind. If you ever get an area 0 and you're like, oh crap, what happened? That's because you're going from...
How do you even get a negative area in the real world?
So an example like this that they had in the book was talking about like... the function of your lungs inhaling and exhaling, right? So like negative area would be like you exhaling that volume of your lungs into the outside, you know, yeah. So basically an area of 0 would be, you know, you having absolutely nothing in your lungs. Like inhaling versus exhaling, combining those together means you have absolutely nothing in your lungs. Does that make sense?
Yeah.
Something of that nature, right? Okay, good?
Yeah.
All right, so there it's the same process again. You're just plugging limits of or you're just plugging your numbers in, just like we've done before. After you take the antiderivative, you can either plug in your x's. You can either plug in your x's into the equations to start with to switch them to use, or you can go ahead and rewrite it in terms of x and then plug them in later. Whatever you want to do, whatever makes sense to you. Okay, so you should have enough information to go and do some of these down here. Do you want to do some of them together?
Yeah.
Yeah, like which one?
Well,
The definite integrals are 13, 14, 15. Do you want to do like a 12 and maybe a 13?
yeah.
Actually, let's do 12 and 14. 14 is going to be a little bit harder because it's a square root. 13 looks exactly like the one that we just did because it was a cubic function. Okay, so let's do 14 first and then we'll bump back to 12. Okay, 14. All right, first step. Step number 1, u du. What are you going to assign as your u value? 1 minus x squared. Okay, du is going to be
2 dx.
-2x dx.
What? Why negative?
Right? The derivative of 1 is nothing. The derivative of -x squared is -2x dx.
Okay.
Yeah? You see that?
Whatever you say.
Okay. Yes? Maybe?
Yeah.
Okay. All right. I've got my integral. Okay. So he is plugged in. This square root of 1 minus x squared is going to be now the square root of...
Do you not have to divide that 2 over?
You do. You will.
So why don't you just do
You
it?
can go ahead and do, I mean, yeah, you're getting ahead of me, okay? So that's going to switch to the square root of u, and then the last thing that I have to substitute for is x dx, which I have right here, but I don't have the -2. So the -2 gets bumped over to the other side, divide by -2, and in that case, x dx will look like -1/2 du, right?
Gross.
-1/2 du. So I'm going to put the -1/2 out here and the du back here. Okay? All right. So now we have to find the antiderivative, but the square root of u doesn't come out nice, or doesn't I can't do the antiderivative yet. We have to make the square root of u look some other way. It is u to the
Second.
half power, 1/2.
Okay.
Okay? 1 over n. What is n plus 1? What's n in this case?
Would it be 2? No, it would be 1.
1/2 plus 1.
1.5.
U to the 1/2 plus 1. Do you see what I'm doing here?
Yeah.
Okay? What's 1/2 plus 1?
3 seconds.
3 halves. Okay, that's what that guy is, 3 halves. So what's 1 divided by 3 halves?
2/3.
2/3, u to the 3 halves power. Okay? Now, 2/3 u to the 3 halves power is really 2/3 and the square root of u cubed. Okay? I'm missing something.
TX.
Nope. What you missing? What you missing?
The other.
What are we missing?
I don't know.
What did we forget about?
I'm not answering, so.
That's fine. What did we miss? What did we forget?
Is the squared on the x?
Nope. I did the antiderivative of this chunk right here.
Yeah.
And I got 2/3 square root of u to the third
Yeah.
power. What am I missing?
du.
Du goes away when you take the antiderivative.
Oh yeah, because just c.
What you missing? What did we forget
Would
about?
it be the negative?
What?
Half?
Yeah,
Okay,
he needs to get multiplied down here. Negative 1/2 times 2/3. Okay, so really, it's not 2/3 out in front. The 2's can cancel, so it is negative
Negative 1/3.
1/3. There's my antiderivative. Okay. All right, now let's switch these guys. Instead of using 0 and 1, I'm going to do this over here. If x is 1 and x is 0, what's u going to be and what's u going to be? U is 1 minus x squared. So if x is 1, what's u going to be?
1.
Nope.
Negative 1.
Nope. If x is 1, 1 goes there.
Yes.
What's that?
0.
0. If x is 0, u is
1.
1. Huh. What a deal. So I'm going to leave my u in that spot, but I'm going to do 0 and 1. Okay? And when I do this, I have to plug in which one first?
0. No,
You have to
1.
plug the 0 in first. Yeah, you have to plug 0 in first, right? The top one goes in first. Minus what you get when you plug the bottom one in.
Okay.
Okay? Good-ish?
I guess, yeah.
All right, 0 to the third power and the square root of that. What's that become? Right here. What's the square root of 0 to the third power?
The square root of 0 to the third power. Like 2?
No, what's 0 to the third power? You're being dumb. What's 0 to the third power? Like
0.
0, and the square root of 0 is?
0.
And 0 times 1, negative 1/3 is?
0.
0. Minus. Okay.
Smart.
What is 1 cubed and the square root of that? 1 to the third power and the square root of that.
Hold on, I'm writing it all out.
Keaton's got it.
1.
1. Okay. 1
Negative
times
1/3.
negative 1/3 is?
Negative 1/3.
Negative 1/3. Okay. 0 minus a negative 1/3 is?
Negative 1/3.
Just 1/3.
What? Oh yeah, no. Negative.
Okay, good. All right, so in that case, we change the limits first. Rather than rewriting the u and plugging the x squared or the 1 minus x squared back in there, we change the limits to be 0 and 1 instead and then got an answer. Okay? That one, 14 is going to be the ugliest one on the bottom there because the antiderivative is so ugly. Okay? The other ones are just powers. Okay, should we look at number 12, though? 12, 12, 12, maybe something like that? Yeah. Okay. The derivative of some function is this thing, and they want us to get back to the original function. So if I'm taking the derivative, this is the derivative of some function, and I want to get back to the original. How do you get back to the original if you're given the derivative?
Move the x up to there. It's
No,
1.
no, no.
Yes.
If you are given the derivative, how do you get back to the original function? If you're given the derivative, to get back to the original. I want to undo the derivative.
Alright, so move the 2 up there.
No, I want to undo the, what's the process of undoing a derivative?
Yeah, I don't know, but I know you moved the 2 up there.
You take the antiderivative.
Yeah, but you moved the 2 up there.
Okay, anyway,
Maths.
sure. So antiderivative means that I'm doing one of these. Okay, I'm taking the antiderivative of that function there. Okay, so I have to use substitution. All right, what do I do now? What do I do now? I have to do the antiderivative of that thing, so I have to figure out what that thing is. What do you do first? What's step number 1 on substitution? Find
U and du.
u and du. Okay, what do you want u to be?
8 minus x squared.
8 minus x squared. What's du?
Negative 2x.
Negative 2x dx. Okay, now I substitute. That's step number 2. So my integral stays integral. Okay, so that thing has been done. I'm going to do this guy next, which is the square root of
8 minus x.
Nope.
No, square root of 8.
square root of, no, square root of, what is 8 minus x squared? What do we call it?
No derivative.
No, what is 8 minus x squared?
U.
U, oh, there you
I
go.
already said that.
You did not.
Yes, I did. I
Whatever.
said you, and you're like, no.
Whatever. Okay, so the last thing that I have to substitute is negative 2x dx. Negative 2x dx. What do I put in its place?
dx. du.
Du, right? I don't have to divide anything over because everything appears in the du part. Okay, so all I have to do is take the antiderivative of the square root of u to u. But the square root of u is like saying u to the 1/2 power. Yeah? All right. 1 over n plus 1 x to the n plus 1. 1 over, what's n?
How are you supposed to plug in 7?
Shh, shh, shh. This way.
Yeah, which one?
1 over. Yes, 1/2 plus 1.
3 halves.
U to the 1/2 plus 1.
3 halves.
Okay? I don't think you're plugging in stuff the right way.
Nope, I am.
1/2 plus 1 is 3 halves.
Yes.
3 halves.
How can you
So this
plug in
is
well?
2/3
Mhm.
u to the 3 halves power. Okay? Plus c. Okay? Now, when they give you the 0.27, that means the 0.27 lives on your line. That does not mean that those are your limits of integration that you're plugging in. So let's plug stuff back in. This is really 2/3 and the square root of u cubed plus c. Okay, but what is u actually?
It's actually 4x squared minus, no wait, what?
What is u actually?
Oh, it's actually 8 minus x squared.
8 minus x squared.
Yeah.
Okay, plus c. All right. So what they're saying is that the original function, this is the original function. We took the antiderivative. We're getting back to the original function. The original function is that thing plus c, but I want to find what the plus c is. I want to find what the plus c is. How do I find what that plus c is?
Set it equal to.
No.
No.
Use the point that they give you. What point did they give you?
210.
2, 10. Right? And I can use that to find c. Does that make sense? Okay, so this one's not a plug in the limits of integration. This is like find the c part. Okay, so 10 equals 2/3 the square root of, okay, that's x squared. So I have 8 minus 2 squared, which is 4. Oh my heavens. Okay, so I've got the square root of 4 to the 3rd power. Do you know what 4 to the 3rd power is?
64.
64. So this is the square root of 64, which comes out nice. That's where we're at now, right? Square root of 64. Are we good so far? Okay, this is 8. What's 2/3 of 8? That's not nice.
2.6.
2/3 of 8 is 16/3.
2.75.
16/3 is 5 1/3.
Say what?
2/3 of 8 would be 16 over 3. 16 divided by 3 is 5 1/3 remainder. That's really gross. They didn't give you nice numbers. Are we plugging in the right numbers? Ah!
What did you say it was? What do you think it was?
2, 7. We plugged in the 2, right? But it's not 10. It is 7 here.
Oh, we're doing 12.
7. So at least we plugged 2 in, right? Because it's still 2. So 2 is fine.
I was doing
2 is
11.
fine. Okay. All right. So we're awfully close to finding C. Now what? Now what?
Subtract over.
Subtract 5 and 1/3. What's 7 minus 5 and 1/3?
Like 1 2/3.
Like 1 2/3. Okay, so whew, that's a lot of stuff. Wow, that's a lot of stuff.
Yeah.
Y equals, so if this was the derivative of some function, and I want to find the original, what's the original function? Y equals
2/3.
2/3
Square root.
Square
of
root.
minus x squared
of 8 minus x squared.
plus c
8
No,
minus
actually,
x squared cubed
plus
1 2/3. Holy cow, that was a lot. Dang. Crazy, crazy. How was that? Gross. We did the gross ones because we did the square root ones. This one should be a little bit nicer, I think, maybe, because it's a power. And powers are a lot nicer to take antiderivatives of than square roots because it doesn't involve as many fractiony things.
That was pretty gross.
That was pretty gross. Okay? All right, good. So you should have an F to get you all the way through 15.
Yeah,
Okay?
man, let's do tomorrow.
Good, good. All right. There you go.